My name is Ulf Bang, and I will demonstrate the upgrades that we have done to the water changeover coil calculation and dialog in our new release of SystemairCAD from September 2022 called H4. So let's start by creating a unit in SystemairCAD, define the airflow. The external pressures are okay, and I just select this default template with the changeover coil in a size 14. Like that. Let's double click the changeover coil. Of course, we can see our defined temperatures over here in the input area. We can see that we have stated we wanted 16 degrees in cooling mode and 22 degrees in heating mode. We can also see that the system is set up to optimize the coil on air pressure drop. It optimizes on the coil type, where we have three types: 3/8, half-inch and 5/8 inch. It also optimizes on the fin spacing, where we have 2.0, 2.5 and 3.0, depending a bit on the coil type. If you go to the right side of the dialog, we have the input area. Up here in the top we can select if we want water, ethylene or propylene glycol, and also the percentage if we select an ethylene glycol, let's say 20%. I can also specify the maximum allowed pressure drop in the fluid circuit. Default is 30 kilopascals. Temperature inputs is done directly on this new graphical presentation of the how the circuit should be built for a changeover coil. We have a primary circuit and we have a coil circuit. So inputs is done directly at this sketch of the circuit. Cooling 6 degrees going in, 12 degrees going out. Heating 45 degrees going in, but the outlet temperature will always be a calculated value since the coil is predefined, and the calculation will find the right balance of temperature going into the coil and going out of the coil with the same fluid flow as in cooling mode. So let's try to calculate this changeover coil like that. Now we can see that in cooling mode with 6 degrees going in, 12 degrees going out, we need a fluid flow of 1.89 liters per second. And since the coil is dimensioned for cooling, 1.89 liters per second will go into the coil with 6 degrees, going out of the coil with 12 degrees, and leaving the circuit here in the primary circuit again with 1.89 liters per second. If we change to heating mode, now we will fix the fluid flow, the 1.89 liters per second, and we will find the heat balance needed in the coil to produce a 22 degrees supply air temperature. So we need 24.7 degrees going into the coil. With a flow of 1.89 liters per second, we will have 22.6 degrees going out of the coil. And now we will circulate 1.89 liters per second here in the coil circuit. But we need to add a bit of 45 degrees water to compensate for the temperature loss we have through the coil circuit. So to heat up the 22.6 to 24.7, we need to add 0.17 liters per second of 45 degrees hot water from the primary circuit. So we will end up having sort of two flows going on. We will have the 1.89 circulating in the coil circuit. We will have 0.17 liters of 22.6 degrees going out of the system to the primary circuit, and that will leave room in the coil circuit for the same 0.17 liters per second of 45 degrees hot water down here in the bottom, to make sure that we get the 24.7 degrees going into the coil circuit once again. There will of course also presented the main data for cooling and for heating here in the directly in the coil dialog. So we can see temperature after the function, we can see relative humidity, capacity, phase velocity, pressure drop air, pressure drop fluid, and maximum heating potential. Maximum heating potential is if we actually put in 1.89 liters per second of 45 degrees hot water, then we will get a supply air temperature of 36.4 degrees. So by just checking this value, you can always make sure that you actually have the heating potential available, even though the coil is dimensioned for cooling situation. And of course, if you have a very, very low cooling demand and a very, very high heating demand, you can end up in a situation where you cannot deliver the supply air temperature. And then of course we need to adjust the input parameters to make sure that we have the right temperatures, maybe by increase the temperature of the hot water going into the system or adjusting fluid flow. So this was a short demonstration of the new input dialog of the changeover coils. Thank you for listening.